So hi, I'm Luis, and for my capstone, I built a reasoning app, specifically a career and college path advisor that uses a chain of thought agentic workflow. So the problem that I'm trying to solve here, it's basically um, students face one of their biggest life decisions when it comes down to choosing a college and a career. However, not always they get good advice. Most of the time, they get shallow guidance that doesn't take into consideration their personal skills, interests, and constraints. And the modern LLM chatbots provide a fast answer when you ask a question, but they don't show their reasoning. So it's one of the problems why students sometimes cannot trust or verify the advice that they are being given. And so one way to fill this gap or close the gap could be by having a reasoning and transparent tool that shows the process of thinking step by step. So this way, students can challenge what they are being told, also learn from that information, and then act on those recommendations. Um, um, we could look at that problem into five different subproblems. As I said already, um, we get opaque outputs from the AI because they provide answers that the students cannot audit. They also get generic recommendations because they don't take into account the specific situations and skills of the students. There is no trade-off reasoning like, okay, here it's what the career that I advise you to take, but it doesn't give you like other options so that you can compare and be more confident about your choices. Also, the data tends to be disconnected. It's not based on empirical data. The LLM basically just tries to guess what's the best choice, and also no actionable next steps. Like, okay, this is the career I'm advising you, but then what do you do after you get the advice on the career so that you can actually get traction on it, like concrete steps on what to do on the next month. So here is why solving that problem is important. And when we see that 30% of US college students change their major at least once in their career, that's a very costly um, decision that could be avoided um, uh, with good advice from the get-go. Also, only 27% of college grads work in a field that is related to their major. So this again hints that they got poor guidance to begin with. Also, the student loan debt in the US exceeds $1.7 trillion. Again, a lot of that is due to wrong path choices that they made from the get-go. Also, the lack of confidence in the responses that they get from LLMs for those that are trying to use those resources is that they cite the LLMs hallucinating and having a lack of reasoning. So they don't really trust. And that's the trust gap that I was mentioning in the previous slide. And so the impact of providing a solution in this space is very clear. If we provide better reasoning, then that translates into better decisions and ultimately less wasted tuition money and time for their choices. So the solution that I'm proposing that is AI driven is by having this reasoning app that is powered by a 4-stage chain of thought pipeline, where it shows you the thinking process, not just gives you an answer, but it explains why it is actually advising you uh, uh, to take a specific career or make a specific choice. So it basically gives visibility to a student by showing all the reasoning through the different steps. Also, we are grounding the decisions on real data by using the career data set that um, I found on Kaggle. And this way, the app is able to provide an output run recommendation that is also accompanied by next steps. Um, so the approach that I followed to the solution was researching on agentic change of thought patterns and LLM reasoning best practices by looking into Anthropic, Stanford High, and agentic workflow literature that is available online. Um, so then I selected a data-rich student-facing problem, in this case, the career college path advising. Then I proceeded to design the 4-stage pipeline using structured JSON outputs, because again, it can be used to feed each step, each of the stages along the way on the pipeline to give visibility to the students on the thinking process. And again, it's grounded on uh, using distilled patterns from the skill to career patterns on that Kaggle dataset that gets injected into the candidate generation prompt to make it more accurate. And also, I show the whole process using a Streamlit UI that teaches, the interface itself teaches the users how the application is thinking. So for the data science piece, again, I use the AI-based career recommendation dataset from Kaggle. Um, it was loaded and profiled using pandas to look at the shapes, the quality of the data, whether there were nulls or duplicates. Then, once knowing that the data was good, I performed EDA using a Jupyter Notebook. So I could look at the distributions, correlations, and the heat map of the skill to careers. Um, so for that, I use some of the libraries that we learned during the class, including Matplotlib and Seaborn. So the key finding was clusters of quantitative data like math and computer skills versus soft skills. The data, by grouping the data in those clusters, I could look at the shapes and decide on candidate paths that the LLM should generate. And basically, the notebook produces these distinct patterns, the JSON file that gets injected into the LLM at runtime, because that's what grounds the reasoning of the LLM in empirical data rather than just relying on pure intuition. So that's what makes this more useful. And the AI technique, again, that was used was a chain of thought, agentic workflow, uh, um, so that we can do prompting and show explicit thinking at every stage of the pipeline, which again is decomposed into four different stages that produce structured output in the form of JSON schemas, and it's grounded, use a retrieval style grounding, which is lightweight, and shows that to the user in the UI using Stringd. So let me show you the app so that you know what I'm talking about. So basically, on the left side here, you see the four stages of the pipeline, which is what the app runs through. Um, Let me uh, just hide that so we have more space on the screen. So basically, the reasoning app, you see, it starts by asking the student questions like, okay, what's the grade level of the student that wants the information? So you can select that. You can provide the approximate GPA also as an input, whether the student is open to relocating or not, and um, also a financial situation, like you have enough money or you need assistance. And then last but not least, you can provide information in your own words, like things that you like, that preferences, things that you are worried about, like, for example, oh, I'm worried about debt. So you can give this information to begin with. And then you kick off the reasoning pipeline. And I ran this previously because it takes several minutes. But let me show you. It basically, when it starts tracing, it goes through those four stages that I mentioned. It starts by doing a profile analysis, and you can see that as part of the stage, you can see what's the model's reasoning on the data that was provided. Like, okay, the student is a high school junior with a 3.3 GPA who explicitly loves math and hands-on building. So it basically gives you, all the reasoning that it is using, which the intention of this is to increase the confidence of the student so that the student knows, okay, this is why the app is suggesting me all this information, right? So you see that it shows the skills, signals, interests, and constraints. Also asks some questions to a student, to make the student think about, the choices he will be making. Then that information is used in the next stage for the candidate generation. It basically here's also where that JSON output from the Kaggle dataset gets injected because using the information from the prompt and that the student provided combined with the real data from the dataset, then a better candidate list can be generated. And as you can see, like based on the profile provided and the providing information, is suggesting mechanical engineering, civil engineering, and three other choices. Then on the third stage is where it does the trade-off evaluation. Because now, okay, that we have some candidates, how good are those candidates? Well, it gives you a fit score, again, based on the initial information, right? Shows you strengths and weaknesses, shows you any skill gaps that you might have that influence the fit score. So it does this for the 5 options that are provided, or the 5 recommendations. And so the student has a lot of good information that increases his confidence in the recommendations that he's being given. So finally, at the synthesis stage, it just takes all of the previous information and condenses that into a summary that the student can read. It gives you a primary recommendation based, again, on all that data, and a backup, again, because it's like, okay, let's say for whatever reason you cannot go with that primary recommendation, you at least have another choice. So you're not just left guessing, okay, what else can I do? The machine is telling you, it's giving you all that information so that you can make an informed decision. And is also advising you of next steps that you need to do. So you get some traction on that. It's not just simply telling you, hey, go study this, right? No, if you want to do that, then these are the next steps that you should do so that to guarantee that you have traction on that. It also gives you honest caveats because it's like, okay, well, it all sounds dandy and, rosy, but also let's be honest about, some of the downsides as well, so that again, you have all the information to make an informed decision. So let me go back to the slides. Um, well, basically, this shows some of the technical details of the solution. I'm using Claude, oops, uh, Claude, which is the Anthropic API, as the LLM, basically because it is really good or strong for the chain of thought analysis. And Python is the main language along with Streamlit for the UI, as you could see. And it has the 4 modules that were already displayed using Pandas, NumPy, Matplotlib, and Seaborn, and those libraries that we learned during the course. And it's approximately 400 lines of code that allows an easy swapping of the datasets in case we want to try with different datasets out of Kaggle or other sources. So again, the AI solution was elaborated using 4 stages, the 4 stages that we saw, with the ultimate goal of giving transparency into the thinking process to transform from a simple chat box into an auditable consultant. So the conclusion is that reasoning beats responding, right? By providing that 4-stage chain of thought pipeline, we're delivering auditable and actionable career guidance, and that is grounded on empirical data to keep the LLM honest, and the design of the UX, the user interface, it's done that way to again show the thinking process as the application is performing the whole analysis, and improvements that can be done to the current application include adding retrieval over labor market stats to make it even, to go beyond what the recommendations that we're getting currently. We can also fine tune that fit score calibration that we saw that is used to show which of the recommendations fits better based on strengths and weaknesses. And we could also do refinement of the multi-term of the application. So this is basically my app. I hope you guys enjoyed the presentation, and